You are listening to The Only Constant, a podcast where we go beyond the usual discussions in technology and business and aim to explore more than explain. Join me for engaging discussions with a diverse range of global thought leaders as we seek to uncover new perspectives and insights in a free-flowing conversation. My guest today is Kurt Cagle, and I am your host, Lasse Rindom. Hi, Kurt, and welcome to The Only Constant. I'm super excited to have, Kurt Cagle from the Cagle Report on The Only Constant today. So welcome, and looking forward to a great conversation.
Thank you. I'm really, really glad to be here. We've had fun getting prepared for it, so this should be an exciting episode.
We've gone through a lot of different topics, I think. There's been some philosophy, there's been some politics, there's been some everything. So I think this is going to be an interesting discussion. I'm really looking forward to it. So, just kick it off and just you're a semantic web legend, Kurt. Really big in that area. One of my friends recommended me to reach out to you also for this reason, and that's why we got in touch with each other. And can you just explain shortly? And I know we don't do explain on this podcast necessarily, but just explain a little bit, what is the semantic web all about to some listeners who don't know what it is, and maybe also why it's so important.
Okay. So when you're talking about semantic web, you're talking about the connectedness of things. Realistically, whenever you have any kind of organization, any kind of construction, really anything, there's some kind of relationships or some set of relationships that basically define how things are related to one another. And most of the time, when you're talking about semantics, it's pretty obvious. That we talk about things like how people belong to organizations, how information gets structured. But that structure is important because it often lies at the foundation of how we describe data. When you look at data in its abstract, a lot of people think about data as numbers and strings of names and descriptions and things like that, which it is. That's a key part of it. But another key part of it is basically the fact that data is usually not flat. It's oftentimes hierarchical. It's often structured. There are often structures within structures within structures. There's a term that a colleague of mine, uh, I'm drawing a blank on her name at the moment. Yeah, I'll think about it anyway. But there's a term that she used that I've seen used earlier called holonic, which means that there are you have structures that basically define substructures and that are independent autonomous entities because they define substructures. And because of that ability to say, look, I have an enterprise, I have an organization, and that organization is made of departments, and those departments are made of people, and those people have different roles and different places within organizations. That all basically falls into the description of being, here is some kind of holonic entity, here is some kind of a way of organizing information that's not just simply here's a tree, but here's how all these disparate things hang together. There's a discipline called data modeling, which has been around for a long, long, long time. Ever since uh, you, you go back far enough, and everything basically comes down to data modeling. But it really was only until comparatively recently that organizations started to say, "Hey, wait, we have a model that describes our organization and our structures and the things within our organizations, the products we make, the processes we use," and that all kind of falls into the category of being modelable, which means in turn that you can query information systems. You can better describe interfaces. You can do analytics on it. You can even get the latest in AI to talk to it in a more compelling fashion. And that's really
Mm,
what the semantic web is all about. It's about this connectedness, not just in terms of how are things linked together on a web page on Wikipedia. It really comes down to how is information modeled,
mm. Yeah, and how can it be interpreted as well, right?
and
Is
how
that
it and
also
how
part
it
of
is
it? That's part of
interpreted
the
once it's
semantic.
in there. Yes, absolutely.
So I always think that I've said before that what was wrong with the Hitchhiker's Guide to the Galaxy, the big robot, the Supermind answering 42, is
Yes,
that that's just a data point. That's not
yes.
an interpretation.
It's
That's
not.
not a semantic understanding. Mm.
Yeah,
Is
and
that kind of the same then?
it is to a certain extent. It's basically and it gets back in a completely different way, but it gets back to the whole notion of AI and prompts. It's what is important is not always the answer, it's the question. If you
Yeah.
if you don't ask the right questions, you're not going to get the right answers. And oftentimes,
No.
the process of structuring those questions is as important to the overall process, as important to determining, what it is you want to know, as is the answers that you come out from it. And so,
But it seems that the internet was maybe more of a unstructured, dissembled mess in the beginning, and then is it the semantic web came up and sort of said we need to make sure that all of the things on the web can interact with each other and can understand each other. Is that the point
well,
of it, or what is it?
not really. That here's where they have a similarity. Tim Berners-Lee basically invented both. That's it.
Mhm.
In 1990 or in 1989, he came up with the protocols for HTTP and HTTPS, which was basically talked about how do I link information from one thing to another, from one server to another. And so that invention, and the set of protocols that he set up to do that communication. There had been other protocols and other ways of working with, the internet, with what had been developed by Vint Cerf and others. Um, but he was really the one to say, "Hey, if you put some metadata around it, and when you click on a link, that link basically actuates to a page that has information that may also contain links." That was actually a pretty profound invention, and it's something that had been around a little bit, but had never really been applied in such a general sense before. Um,
Mm,
his invention on the semantic web was actually more kind of the realization that, okay, this just doesn't describe web pages, it describes everything. If you can describe information in a web page, and say, well, what is it that that link actually entails? What is the significance of that link? That link basically has a certain limited degree of semantics of understanding. You look at it and it's not just here's a pointer to a page. More often than not, it's also metadata text that's around it that entitles it, that gives it context. That when you then click on it, it allows you to enlarge your context dramatically. And in many
mm,
respects, much of the development of the web has ultimately kind of come down to this realization of and conflation of the nature of links and linking with what bridges that. Now there was actually fairly early on there was a couple of different standards that developed as part of the HTML specification. One of them was called Xlink, and it's for the most part has thankfully died a hideous death, or at least an obscure death. There's a few things that still make use of Xlink, but for the most part, it kind of has evolved into a lot of other things. But that was that was really a first attempt at being able to say, maybe not all links are one dimensional. Maybe it's not just, hey, I'm linking on a thing. I'm actually linking to a collection of things, or
Mm.
to a set of things. And that duality, that ability to say, hey, look, there's a link to multiple entities, is not something that's actually obvious when you look at the web, but it is something that's very intrinsic to when you're talking about semantic web and RDF and all of the underlying really
So
stack
it's
of
about
technologies.
making the internet a structured exchange of information, more than just a nonsensical link database. Is that am I completely off here?
Well, I mean, it's the internet is an example of a linked system. Okay,
Mm,
the semantic web is basically more of an abstraction. It says, let's talk about links and relationships. How does something relate to
mm,
something else? And you can link, you can basically use identifiers that say, okay, here's a resource. And that resource, that thing that you're pointing to, has an address. That address is basically something that's addressable on the web. And you then have a relationship, which is the link that you're creating from your current location, which also has an address. And so,
mm,
if you think of it as okay, one way of describing the internet is basically through semantic linkages. That's perfectly fine. It's a very, very common use case, and it's something that actually forms a lot of things. But at the same time, it's more than that, because it says, now let's abstract this from, here are web pages, to here are things in general.
mm,
The idea of basically saying, for example, um, I'm Kurt Cagle and I have a pet cat. And that relationship, this cat is my, this is my cat, is essentially a link. It connects these two things.
mm,
Now, there's no physical link. There's no addressable entity, but I could very well say, if I wanted to, okay, here's a page representing a bio of Kurt Cagle, and here is a page that represents Kurt Cagle's cat, Bright Eyes. And so you have that link that exists, and you can basically then say, here's a relationship that exists between them. Um, that link is not necessarily a URL, or it's not necessarily some kind of a hypertext link. It is simply a link. It's a
no,
connection point. It's just
yeah.
that you can use one to basically talk about the other, if you will.
Yeah, so it's part of the data that's behind the web, basically, and how
Yeah,
it's connected, how things are connected on web pages and information on the internet in general, not just web pages, but in general on the internet, right?
yeah. I mean, if you look at it in terms of, well, let me give you an example. I have, let's say that I create uh, a link in the semantic web where I say, I have published this data set, and that data set may be in JSON, or maybe in XML, or maybe a CSV file, or an Excel document, or anything like that. That that thing I'm pointing to is essentially an entity. It has an identifier. And that identifier basically is one way of naming that object and saying,
Mm,
okay, here's the thing that is named this, and whatever this is. It may be a long string, it may be a GUID, and it may be any number of different representations. But the thing that is named this has this relationship. Now, there's data inside of that. That file has information to data, and I don't necessarily say anything about what that data, what that relationship is, or how those things connect. But I could. And I
mm,
could actually say, okay, let's take this information, let's take this JSON file as an example, and we're going to recast it using the Resource Description Framework, or RDF, into a form that basically consists of linkages to other things and linkages to data to strings, or literals, as we call it. In that particular case, when you're talking about these linkages, what you've done is actually gone one step further and say, okay, in this JSON file, or in the thing that this JSON file represents, I have broken it down into, here's a description of, here's multiple entities in a JSON array, and each JSON entity in turn, each record, if you will, is now addressable. I can actually refer to it by an address, and I can say, okay, here is a link. And I'll give you an example. I have actually working on a file right now consisting of about 1,000 comic book characters. Now,
Mhm.
I'll get into why about comic book characters in a bit, but it's a really useful data set. And it's useful. The reason it's useful, I'll actually jump in but the reason it's useful is because it's something that people relate to. They understand what a comic book character is. And I could talk about some very basic concepts without getting into things that might get political most of the time.
Mhm.
Or might offend people in some way. It's kind of like, okay, it's something that's a little more exciting than a spreadsheet that shows cost and benefit analysis. But you can do the same thing with a spreadsheet. It's just the names that we talk about become a little bit different, and they're more boring. And I don't like boring. I
Yeah.
like to actually have some fun with my data. Um, so anyway, I've got this listing, and I can basically say, okay, I've now created a pointer to Batgirl, from the 1960s TV show, Batman series. Within
Mhm.
that pointer, I can then say, okay, what, where did that character appear? What shows did that character appear in? What comic books did that character appear in? What publishers was responsible for the generation of that character? And those are all basically links to things that has they may have their own address. DC has a publication. It has an address. It has a way of describing it. Even concepts that are more generalized, like the character has red hair. Well, I can say,
Mm.
hey, look, I've got a selection of hair colors, and among them is red. And this character is a redhead. And so I have a hair color redhead. And that allows me to go in and then say, in the aggregate, now give me all comic book characters that are in DC that also are redheads. And
Yeah.
you can do that with a JSON file. It's not hard.
Yeah, but that's also what I meant with saying that it's not just disparate data. It becomes connected data.
It
It becomes
becomes
data
connected.
that's easier to retrieve and ask questions to. So it's not just the web is not just something that's you put something up and it's not connected to it. It doesn't make it's just there as a blob of text,
Right.
but it becomes something that's connected to the rest of it. So the links like in and this is something that I know also why it's like a graph representation basically with nodes and edges, right? So it
Yep.
gets connected to things in sort of this sphere, right? That's the point, isn't it?
I mean, it is. We're and I haven't mentioned graphs, and it's probably good that you brought that up. But that's essentially what we're modeling.
Yeah, it
You're
is.
basically saying, everything that is in a graph, to kind of put a little historical perspective. We talk about nodes and edges. Now, back in the 18th century, there was a mathematician by the name of Euler, Johannes Euler. And Euler was big. Euler was kind of the superstar mathematician of the era. Um, but among other things, he talked, excuse me, he talked about um, the connectedness of things and basically describe what now is known as graph theory. And graph theory essentially says, okay, there's a number of laws that emerge about the way that we connect things. And those things that we connect, those nodes and edges become graphs that essentially
Mm.
describe some aspect of information. And so he basically used the terms node and edges because a node is actually in I want to say it's in Dutch, but a node is essentially another word for knot. And the edges then are essentially the ropes that connect between the knots. And that
Mm.
creates a net, just like a fishing net, that is then used to cast off. So when I
Mm.
go and try to catch fish with my net, what I'm doing is networking. Um, I bet you probably didn't know that they were related, but yes, networking is
And
in
I did.
fact related to fishing. Um, but that ability to describe networks of graphs um, is really kind of fundamental because graphs are everywhere.
Mm.
When you describe any kind of data structure, you can basically reduce it down to its atomic level of being a graph. Any kind of hierarchical structures of graphs.
Well, I
You can
just today, just for example, I just today had a discussion about just mapping out what's going on in an enterprise. An enterprise, very basic workshop, enterprise architecture thing. I said, well, let's make a list of all the applications you work in, right? Let's just structure it some way. Your company, then your vendors, your customers, your affiliates, and the public entities you interact with. And then
right.
let's make a lines between all of these entities with what you do between the different things. And there you have it, right? So all of the systems you work in, that's a node, and everything you do between them, that's an edge.
Yep. Exactly.
And then you have a map. That's a graph table. So it's a way of structuring, as you say, understanding what's going on, how are things related, and that's what the semantic web is all about. And that's also to some extent, right? I know it's not completely the same, but it's also in sort of the same way. And now we get to the AI thing that the way that the generative AI is built, the LLMs are built in a sort of graph. There's these, there are these weights that sort of react to each other
Yeah.
because they have a connectedness, right, between each other. But they're just numbers because they've been encoded. But the basic thing is still there, isn't it?
Well, there's a clue there. What is an LLM? I first of all,
Mm.
just to use the term to define the term, I've heard a lot of people talking about it as a large language model, and I think that's actually a bad description because it doesn't have to be large; it can be quite small. Um,
It's
but
also a number model, to be honest.
yeah, yeah.
That's another thing.
But if you look at it in terms of a language learning model, that actually is a term I'd love to be able to see propagated because I think it's a more accurate one. But when
Mm.
you look at a neural network, the key is in the term network because if
Mm.
you look at any picture that describes a neural net, you will see at some point this connection where you have a lot of lines coming in, then you have these, what looks like a mesh
Yeah.
going back and forth, and there's a lot of hidden layers which you don't talk about. And then on
Mm.
the other side of the hidden layers is basically the weights that get generated as part of this. And there's a whole process whereby you create those weights. But what you're doing in a neural net is essentially saying, I'm gonna create a vector, and that vector um, is a description of the various properties about a thing. So, as an example, an example I used fairly recently, I just kind of spontaneous. I have no idea what actually drove me to do it, but I got to thinking about fictional captains. You know, why? It's an interesting set. It's kind of like superheroes. Why do you talk? Well, I mean, think about it. You have Captain Picard, you have Captain Kirk, you have Captain Jack Sparrow, you have Captain John Barrow. You have Captain Crunch, Captain Kangaroo. I mean,
Captain Crunch. I was just
it's
gonna say
it's
that.
it's
Yeah.
it's a whole litany. If you start putting things down and saying what lists of fictional captains do I have, the list becomes surprisingly long.
Hmm.
But when you then say, okay, describe the properties of a captain. And, I sat down with that and said, okay, there's a lot of properties. Is it male or female? Is it, does the captain have a land based command, a sea based command? Is the captain, is the character portrayed as a real person, or is it a cartoon, or is it somewhere in between? Is the captain humorous or serious as an actor, as a portrayal, so forth and so on. You can basically describe a lot of different attributes that make up the notion of captain in the aggregate. And in fact, you
Hmm.
can talk about thousands of these attributes in theory. Um, and so, what happens, and this is a process called vector encoding. But what happens as a process then is that you take this list of things and you normalize it. You say, okay, eh, express these features as some value between 0 and 1. Is he serious or is he comical? If it's serious, then he's over at 0. If it's 1, then he's comical. If it's 0.5, then it's somewhere in between. Um,
Hmm.
and so that's once you do that with all of these many, 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 many different attributes, a lot of which may actually have, it doesn't matter, but they're still there. But once you do that and then can say, okay, now encode this as a vector in a large dimensional space, where you have thousands of these attributes, map it, and then say, okay, I'm going to look for those characters that are kind of serious but not kind of humorous, that are on a ship of some sort, and maybe a
Hmm.
spaceship, but on a ship of some sort, uh, and that are usually portrayed as being a live actor, but may in fact sometimes be portrayed as a cartoon character, but mostly live actor. That sets up a coordinate that allows me to look into that space and find a concept.
Hmm.
Find an example of that which most closely matches this particular vector. And in that
Yeah.
process, what happens is that you also get other things that get closely related to it or not so closely related to it. Sometimes those relationships are um, yeah, sometimes those relationships are okay. If I have Captain Kirk, Captain Picard is probably not too far away. Captain Crunch, on the other hand, may be completely, in a whole different part of the space.
Yeah.
Um, and so that space of information that you have, if you then say I'm going to create a sphere, but it's a sphere that's many, 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 many dimensions. Think circle, sphere, hypersphere. You know, it basically just says there's a radius of intent that you're looking at, and as you get that radius bigger, more things basically fall into that radius of interest.
But
And
the system you're describing can be queried here, right, Kurt? So
but
we can
yeah,
actually
because
ask questions to
because
it.
when you ask a question, what happens? Basically you get a tokenizer that reads in the words or the collections of words and then says, "Hey, I'm going to take this collection of tokens, this string of tokens that I've broken into some kind of an array, and I'm going to convert it into a vector as well. And then I use that vector to say how many things are closer to this particular point that I'm talking about, and how many things aren't. And if I grab the stuff that's near to that point, chances are that if my circle is big enough, I'll get things of interest. I may get things that have
Mm.
no interest whatsoever, but probably not that many because information tends to cluster. And so,
Yeah, so you get if you ask all the right questions, you in a query like that, you'll get to Captain Kirk if that was what you were asking for, right? So
yes,
or whoever
but you may also get
or
Captain
you get to
Janeway, and you may get uh, you'd probably not immediately get to someone like
but what
Captain
if I
Crunch or
asked it
Captain.
precise enough? If I have this precise enough query, I would get to Captain
Oh,
Kirk, wouldn't
sure,
I?
but that's the point.
But that's the point.
Yeah.
But that's the point. But that just leads me to the LLMs, right? Because you don't get that there necessarily. Is it then not a graph because you don't know
It's
exactly what you're going to get all the time?
well,
It's not
it's
just a compressed database. There's someone said that the LLMs are just compressed on the data they've been trained on. It's a sort of compression to some extent, but it's not
well,
really, is it?
it is and it isn't. It is in that you have condensed a lot of information into a very small space, mostly empty space.
Mm,
However, where it becomes interesting is that um, relationships are themselves um, can be described as concepts. And so, once you start looking at it from that sense and you start saying, okay, there's these fractal structures, and that's what you're getting at this point. You get enough information, you get a fractal. But there's these fractal structures that basically are out there, and because they kind of form these clusters and then strings between clusters, there's kind of a stronger or weaker intrinsic um, graph that can be teased from it. It's not really there. It's something that if you have enough information, you can say, okay, look for the tendrils that are strongest,
mm,
and use those to kind of connect the things that we're talking about. And then after that, you can then say, well, what is the nature of that connection? And
mm,
usually you can describe it as simply being okay. That connection is something that says um, Captain Ship or Captain Kirk Enterprise. And if
mm,
you then look at the clustering that you have, and then say who else is part of the Enterprise, and then you get a kind of a cloud of information. But if you look at it fine grained enough, you actually get these nice little tendril structures that pass throughout all this that kind of form something like a network. And this is something that a lot of people that are now experimenting with different ways of visualizing what goes on inside of an LLM, inside of a neural network. Which and there's the same thing. They're just very big neural networks. But
mm,
they're looking at that information and then saying, okay, what does this look like? And it's clearly a fractal structure. It is clearly something that you look at and say, okay, these things are, you have these notions of essentially um, substructures that appear and repeated characteristics and patterns. But at the same time, those clusterings that you have can also essentially be represented in a much more simple fashion with something like a graph, an ontology in this case.
mm. So
So
I'm trying to follow along here because this is getting into something that's to a business person like me becomes a very very esoteric, almost esoteric tech, right? Isn't it? Talking about LLMs being fractal structures, isn't it, Kurt? I think
okay,
that's
well,
almost a definition of it, isn't it?
yeah, I
so
mean
so
it
just
is,
just
but
yeah. This
to,
is wizards. This is wizard stuff, and you with your beard, I'm not really surprised, but
well, it's something I've had a suspicion about for a while now. I had
mm,
I've been following fractals pretty much since they kind of exploded on the scene in the 1980s. And
You have a pattern thing, right? Don't you? Like they're seeing everything as a graph, you said, and now
yeah, yeah.
fractals and everything. That's also a way of seeing the whole world as something mathematically expressed, basically, isn't it? So,
Yeah, yeah, it is. I mean, it's kind of like you're looking for patterns, but you're also looking for relevant patterns. Patterns are all around
mm,
us. We have
mm,
patterns that occur all the time. Most of the time, those patterns are meaningless.
mm,
The key basically becomes finding those patterns that actually have meaning, that are
yeah,
some.
obviously.
Um, so
That's maybe also the problems with the AI we have today, right? Finding the patterns that make meaning, that makes sense to us, isn't it?
well, yeah.
Actually, just as you said it, right?
Yeah, I mean, the thing to keep in mind when you're talking about LLMs, and we talk about this term called hallucination, and
Hmm.
I've made this almost a mantra. It's something I have to repeat occasionally
Hmm.
on my blog, and that is that an LLM, a neural network, is not a database. It is a generator. And it is a
Mm,
generator primarily because you're no longer talking about things that you can make clear assertions about with a high degree of fidelity. Instead, you're basically talking about what are the things in this radius, and when I make a query against it, how do those things relate? I don't know. No, I have no
mm,
structure. I have no information. That's why oftentimes what happens when you make a query is that in order to be able to make use of it, you have to posit some kind of use this structure to represent this information. And at that point, everything kind of coalesces, sometimes well, sometimes poorly, but it usually does. Um,
yeah.
so that's why, when you look at a neural network, you say, no, it's not quite a graph. It's one of those structures I would actually say is not itself a true graph, but it can be represented and can take structure from a graph definition, from as I've
Mm,
used the term ontology here before, but think schema. You can basically say utilize the schema to be able to give me the information in a form that makes sense here, and it'll go off and it'll basically grab multiple vectors based upon your query. You're basically saying, okay, I have this whole cluster, and each of these are creating little spheres that create little Venn diagrams, and it's what gets caught in the Venn diagrams that basically come
mm,
back to you. Um,
mm,
but when all that comes back, you then just have something that interprets, that creates a shell, that creates a template, that then interprets this and puts it out into a form that we see in some kind of chat context. Now the same thing happens
mm,
with imagery and with video, where in this case what you're doing is you're saying, I'm going to take pictures and I'm going to label those pictures. There's some commonality in the theme here. And those
mm,
pictures can then be compared against other pictures, against kind of a baseline, and said, okay, this little piece over here looks kind of like a face. I'll kind of store that as a face in my information. And this little piece looks kind of like an eye. And this little piece looks kind of like a shoulder. And, these pieces in composite can then be used to say, all of these images that I have sort of kind of classified, I can then kind of start pulling together to create a thing, a Frankenstein thing, but a thing.
mm.
And that thing then doesn't necessarily have to exist. It doesn't, it could be something that is completely and totally made up. Um,
Yeah.
which is one of the real wonders about LMs. That's one of the things I like playing with these, with
Yeah, but
this,
then
especially.
it completely makes sense, right? To me, like then you make this graph net, this huge net. That's how I see it now. And then when your query, with your prompt, you get closer, you close it down to say these are the things that gets activated, and
Yep.
it's a small sphere, area of the LLM, and then it produces something out of that where it says, okay, these are the strongest connections that I currently see from what you've said, and it will always have something that is the strongest connection in
Yeah,
it or something like that, and then that's what you get. That's the answer you get. And that's why sometimes you get something that looks absolutely crazy, also in images, because it's you're basically querying, I don't know, a dictionary. You're going to a page and say, just merge everything on this page. That's a different way of structuring data, right? A dictionary. But every word on this page, put it together in an image, and there you go. Because you sort of flip to that page, but here you just flip in a graph structure of some sorts. Isn't
yeah.
that is that correctly understood, right?
I mean, it's pretty close. I think
Yeah.
I think what happens. Information is fractal. Um,
Mm.
that is, that's an important. That's the reason that LLMs work. If information wasn't fractal, then LLMs wouldn't be possible.
Yeah, because
Um,
things, big structures or things that they connect, they then reproduce in smaller structures that also have connections to other smaller structures that then
exactly.
reproduce in smaller structures that have connections to other smaller structures, and the form sort of just goes on forever, right? Until, I don't know,
Right.
particle level or
And
something like
and
that.
we
If we
call
go there.
we call that a what's the term? A context.
Mm,
So you'll often hear references to some of these big LLMs. I think GPT has a context of about 150, tokens in terms of really how large, how deep that fractal structure can get before you get to a point where you say, I just don't have enough space to be able to get tinier and tinier.
mm.
If you look at some of the newer ones, Grok, not the there's two. There's Grok, which is the
Yeah, the GROQ, right? That's the one you're
GROQ
talking
versus
about.
GROK.
Yeah,
But
so we're
the
talking about the Q one, right?
Yeah, I'm talking about the Q1, and the Q1 basically has a context of around 1.5 million. I think Gemini has a context around 1 million tokens.
Mm,
And in those cases, you can get finer and finer and finer details, probably to a point where you actually get details that aren't really part of the underlying structure at all. They just happen to be part of the information foam that's out there, just kind of like the foam of reality.
mm,
Um, but the larger the context in general, the deeper you get into the fractals. Um, but at the cost of more computation. It takes a lot more energy to basically do 1 million term context than it does to do something that's a tenth the size. Um,
mm. But I think actually that explains to me in a much better way than I've know how this works, and I think it makes complete sense. I hope people also will bear with me asking the questions and actually asking you to explain things, because usually I say that we explore more than we explain on the podcast, right? So
yeah.
that's interesting. But it also brings me to obviously a question saying, what is is this intelligence, Kurt? I've asked Stephen Pemberton the same questions in the second episode, so I think it's interesting to ask you that question as well. Is this intelligence, or is this just? Stephen was very dismissive, right?
Yeah. Well, I mean, he had good reason to be. Um, I'm
Don't
still.
pretend you haven't thought about
Oh
that. I
God,
know
no!
you've thought
I
about
have
this.
I have all kinds of thought. I mean, this is the fundamental question of
I know.
philosophy
I know
today.
you'd love this
It's
one.
I'm just trying to kind of articulate what I'm feeling today about it because it changes. Um, I think when we define intelligence, when I was describing neural nets, or excuse me, the semantic web, I talked about this concept of holonic, or holonic
Mm,
entities. And holonic entities basically are ways of dealing with organizations as if they are organizations of things, what I call assemblages. But dealing with organizations that basically have some kind of agency in their own right. Um,
mm,
and if you think about intelligence as basically being the communication that exists largely within those holonic entities, whether they be an organization, for that matter, a person.
Mm,
You have different, our brains are not one thing. Our brains are actually about 24, 25 different subsystems, if you want to think of it in that.
mm,
And, some of those are dealing with emotional thoughts. Some of them are dealing with autonomous functions. Some of them are dealing with higher order thinking, as we would call it today. Um, but ultimately, the intelligence that happens is essentially the language that is used internally to communicate. From a purely physiological level, that intelligence is largely chemical and electrochemical in nature. There's some arguments that it may actually be quantum because of the nature of synapses.
mm,
But that means that you can talk about intelligence from the perspective of saying, um, you know, in an animal, and humans are animals, you have this biochemical language going on throughout the brain that's initiated by calcium exchanges and electron exchanges between various types of membranes, and all kinds of other things that I won't get into here.
mm.
um, and that's intelligence because it's a language, it's communication that's occurring within your head, and to a certain extent that also occurs externally to you. So, if you think of it in terms of that language being something that we can approximate as intelligence, yes, human beings have intelligence. That intelligence is something that is actually very similar to the intelligence of apes. A little more
Mhm.
sophisticated because there's a few additional things that we have that our nearest cousins don't. But they're largely evolutionary in nature. The same things with cats and dogs, same things with really just about any chordate, anything. There's kind of a cutoff point where you have brains that are kind of structured sufficiently to be able to handle um, the presence of at least a cerebrum and a little bit of a cerebellum. So mammals all have cerebellums. Um,
Mm.
a cerebral cortex is essentially is that wrapping of things around other brains.
So
But
today you're feeling that it's kind of intelligent. Is that what you're getting at?
well, sort of. I mean, where I'm going with this is that animals have intelligence, people have intelligence. You can argue that stars and planets have a certain level of intelligence, but that intelligence is largely just processing a set of processes. It's
Mm,
communication that exists between various components within these holonic systems. Now,
mm,
an AI is not a human being. An AI is, in fact, a lot closer to what I would call a corporate being, in that it is
mm,
essentially something that is made up from people and people's interactions.
mm.
We are the medium by which an AI works.
Yes. I love you
Okay.
saying that. And I think, and the corporate being, I love that. I love that. That makes so much sense. And I think also it brings so many thoughts to me, also around things I've said before that I said in the episode I had with Nosobina. I was saying that, this works with human. This is a human technology
Yeah.
more than any other technology. And that's also why talking about um, replacing people, right? With AI
Silly.
is off because AI doesn't exist without people. It's
Yes.
it's
I mean,
well
the, the here's
this is
here's
social sciences, right? This is not something. This is social sciences.
it is very definitely social sciences. It's
Yeah.
when you get right down to it, the what we're seeing here is that AI that we're talking about. Yes, it may be conversing, between me and you because it's using mimetic interchange. The interchange of memes of little components of thought. It's using mimetic interfaces to basically handle the transmission of information across the system. Um, but a typical LLM is having hundreds of thousands or even millions of these conversations simultaneously.
Mm.
It's not a human being. It is not anywhere near being a human being. And the kind of intelligence that it has is not itself going to be a human intelligence. Now,
Yeah, that yeah, no,
if you take the humans out of the equation, artificial intelligence gets a lot less interesting.
true.
Um, because at that point it's kind of like, well, okay, it's a protocol for communication, but it's a really vastly inefficient
Have
protocol.
you seen the Tom Fishburne Have you seen the Tom Fishburne comic where he has Marketunist, where he
Yeah.
has someone saying, "Oh, I just had AI write this email. It's brilliant," and then someone else had, "Oh, I just had AI read this email."
Yep.
So
Exactly.
you have these two frames, and then it becomes meaningless, right? Then AI doesn't make any sense. There's no human in that loop. It's just pointless production of text.
Well, it is and it isn't. This is if it's kind of like if I have a um I set up a process that sends out to my newsletter people. I've got 8,000, 9,000 people on my newsletter at this point.
Hmm.
Maybe a little inflated, but somewhere in there. Um, but either way, the when I send those out, chances are that only about 20% of them are going to get read.
Mm.
And that's fairy tale. That's actually pretty good when you start talking
Hmm.
about the way things are going.
Yeah.
But the question is really, does that necessarily change anything? It's just simply, these are messages that get sent and received.
Mm.
And I don't think it really changes all that much if the way the computers communicate with one another um, is actually very different from the way that people communicate with one another, or somewhat different. When computers communicate with one another, what they will probably end up doing into the future is essentially, here's a set of prompts. Here's a message that gets sent that says initiate communication, and we will do a handshake arrangement until we come to some kind of a consensus on protocol, and then we'll use that protocol for communication. Um,
Hmm.
and
That's also what humans have done, right? The way
this
we've
is what you and
invented
this is exactly
writing, the
how
way we, yeah, and language evolves this way, right?
yeah, it does. I mean, it's exactly the same thing. But this kind of gets
Well, my
back
point is
to
just, the point is just, we've made systems to make structured data, to make even more, civilization. Civilization and organizations and everything, human society is all about structure and things, and making it more structured and making more order in the world. That's the good gods all the time. That's the order gods that makes order, and then the evil gods are the titans and the trolls in the Nordic, right? That's the evil chaos gods, right?
yep,
That's the point. That's the whole point of civilization is creating order, and we believe in the good gods, and we try to do what they want to do, and blah blah blah. So, um, but if you just have these LLMs take all of our structured data and turn it into something unstructured in a conversation all the time, some other AI tries to read that out, it just becomes this unstructured thing. I think it's increasing entropy. It's reducing civilization. It's
yeah.
rolling back what we're trying to achieve here.
Well, I
If you
mean
use it just to generate crap.
that assumes that assumes that you're taking sides. Um,
Yeah.
I'm not sure that you can or should. To be perfectly honest, what I find funny about this whole discussion about hallucinations is that LLMs are great at hallucinating. They're great liars. They are
Mm.
fantastic liars. They're better liars than people are. Um, and that's saying something because we've never built a machine that lies before. And that to me is actually the thing that I find so remarkable about this is that we have created a natural storyteller. We've created something that is capable of building a narrative, and a narrative is fundamentally a lie. It is fundamentally taking something that may have existed, that may have been may have been parceled out in some way, but it then says, here's an interpretation, or here is a different way of thinking about it, or here is something that makes it more intriguing. And it is
Mm.
that ability of an LLM to lie that I think is actually one of the biggest factors in what it can do, but it's also one of the biggest limitations when you look at it and say, okay, be truthful all the time. You
Yeah,
can't.
but
I mean,
that's that.
it
You're right. You're absolutely right. That is actually, it's very poetic. It's very beautiful. It's, we made an unreliable machine that lies, and we don't know which direction it's going to lie in. It's just going to be, what is it going to say?
it's
What's going to happen
chaotic.
next? We
It's
don't.
unpredictable.
Yeah,
Yes, and
so
that's
we've
lovely.
created the technology titans, right? That's what we've made, isn't it?
Well, I mean, the Titans serve their purpose too. It's
Yeah, they did.
that's the thing is that too much order leads to stagnation.
Now
Too
it
much
becomes
order
very
basically
Eastern
means
philosophy here, Kurt.
yeah.
It's yin and yang we're talking here, right?
Yeah, I mean, you need to have that tension between the two, and up until now, for the most part, it's been largely or order oriented. It has been largely focused on
Mm.
saying we must have structure. And don't get me wrong, I'm a big, big, big proponent of standards and structures and things like that
Yeah,
because
you're
I
a
think it
semantic web
facilitates.
legend, as I said in the
Yeah,
beginning. That's what we talked about the first 15 minutes. It's the semantic web, which is a way of structuring the
r-
unstructured,
yeah.
basically.
But in a way, you have to basically look at it from the standpoint of saying, okay, it's a left brain right brain comparison here. The left brain is largely analytical and text based and the like. The right brain is largely exploratory and inventive and creative in a way that is we haven't really thought about our machines doing for us. And it's a little frightening because it's that creativity that ultimately I think is one of the things that we as human beings tend to pride ourselves on. And it's a little humbling when we realize that no, we can automate that as well. Um,
I think actually I disagree a little bit on that, right? I think that, yeah, we tend to say that the creativity is what we live for and everything. But what we're actually doing in most of our lives, most of the living hours of our day, of the hours that we have, we use to create structure, and we use
yeah.
analytical brains, and we follow
Well,
laws that are structured. We build civilizations, we build buildings, we make straight roads, in the US especially, those straight roads everywhere, right? It's very ordered in a chaotic world. That's what we do. And then we say, oh, that was a lot of analytical brain, and now we just, oh, let me just try to, because the creative side is giving us the energy to do things, to move around.
yeah.
Computer doesn't need that. It actually does. The funny thing is, you said it was a corporate being, but corporate beings really don't need creativity. They need more structure. But we need.
Well,
There's
actually,
something going on here. You
I
see?
would disagree with that very, very much so. I think in many ways the problem that most corporate beings have, and I'm not talking about any corporation, is
No.
that it is a corporation is a machine. It is a machine. It is a machine basically intended to fulfill a certain task within a social context, or within
Mm.
an economic context. What that task is. That is, I'll leave that argument up to the economists because by and large it really varies depending upon who you ask. But the key point is that it's a very mechanistic entity. It's something that it's nothing but structure. It's nothing but process. And in general, most organizations, especially as they get larger, become so focused on maintaining structure, that oftentimes their purpose, the original reason for creating the entity in the first place, gets lost.
Mm.
And so it tends to shy away. I think that, as if you think of it as an animal, it tends to shy away from chaos. It tends to move away from things that could possibly break down its structure, because it's a very fragile being when you get right down to it.
Yeah, yeah.
Um,
Yeah,
and
social
and
construct, but that's also why we make that's deep state, right? That's why we make those things, because it should be stable, for at all costs stable, because that's what we need to like an
well,
ant colony
I
to
mean,
exist in this
you can argue
structure.
that, but I'm not sure that's true. I think that society needs both. I think that you need to have stability in order to be able to build on, but you also
Yeah,
need to periodically break that stability, because too much stability basically induces paralysis, where the ability of the organization is no longer
yeah,
is no lo- the purpose of the organization is no longer being met.
yeah. And I
And
also
yeah,
I spoke about this with a friend the other day, where we talked about the way getting things structured to some extent, and that generative AI, in the way it can, and it can and analyze unstructured data. I'm really that's the thing that triggers me the most. Almost, I love the way lying is. You made me think of that, and I love that. That's a brilliant. It's very beautiful. But I like from a practical point of view, I like the way it can analyze unstructured stuff and turn it into something structured. And that means that it becomes a creative force for the enterprise to sort of expand itself in different smaller parts of it. So because now it can actually grasp something, like something that spreads, like an, I don't know, an organism, or a something infected. It sort of grows into something that's now unstructured as well. It can now structure the unstructured. So I see it that way, as organizations can grow with AI, because I think this is a paradigm shift in the way we've worked in technology and IT and digital, is working with unstructured. We never did that. That's not
yeah.
the point. That's not how we work. But now we can actually do that. And
Well, I mean,
because it can lie, it can also understand the things that it's not supposed to understand. There's something connected there that's really beautiful and
yeah,
and 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 very big for me.
yeah. No, I would tend to agree with that. I think that um, what we're doing, when you get right down to it, is we're hacking language.
Mm,
And language and intelligence have a very, very intimate relationship to one another.
mm.
Language itself is neither structured nor unstructured. It is something that evolves. It is something for which the rules are not rules so much as suggestions.
Mhm,
It is something that is tied into our cultural understanding, while at the same time allowing for foment against cultures that have become too stable or have become stable in the wrong way. Um, and at the same time, it's a very powerful tool for essentially shaping societies. And that's why you have to think of it. Talking about assemblages again. Um, Corporations, for-profit companies, are one form of an assemblage, but there are many others. A government an assemblage. Governments at all levels are essentially assemblages. Um,
mhm,
any organization, any university, any time that you end up with these, where you have people that are essentially interacting with one another, to fulfill a certain purpose, you generally have some kind of an assemblage that forms around them, and
mm,
uh, that assemblage both has a tendency to amplify the voices of certain people within that assemblage, but it also has a tendency to shape the thinking of the people within that assemblage, within that organization.
yeah.
And think about what is an organization. It's a way of organizing things. It's a
Yeah.
semantics, it's an ontology.
And
Um,
language is the original organization,
yeah,
I'd almost say.
exactly. It is. I mean, it's where everything else derives. So if you have
Mm.
and you can take that, and that's why we get back to this concept of intelligence. I was thinking about this the other day when I was had my window open, and I've got some green belt back behind our house, and I could hear the birds calling to one another. And those birds are have essentially developed into an ecosystem that is outside of the space of every bird itself, to the point of saying, okay, you have these nodes, and these nodes are communicating, saying, get out of my territory, stay out of my territory, or I'm
Mm.
looking for a mate, or I'm hungry, or don't get too close to my nest, or things like that, that essentially provide this back and forth communication that says, okay, the birds may or may not be intelligent, or well, they are, but the intelligence of the ecosystem is actually what is as fascinating there, because it's watching this interchange of information, and that interchange can look really chaotic. It can look like there's
But
no patterns.
yeah, but there
Um,
is a pattern definitely. But it's all the funny thing about this is also, we sent out was it with Voyager 1 there was a record or instructions for communicating with us, or was it Pioneer? I can't Pioneer, right?
yeah,
Pioneer had a record on it, didn't
yeah.
it? Yeah. So we tried
No,
to
Voyager 1. It's Voyager 1.
But we send out something that, to try to talk to aliens out there,
Yep.
because maybe they could understand it. But the point is, we have tons of aliens on Earth we can't talk to, like
Yeah.
cows or crocodiles. They're all intelligent beings in some way, and they have a language. We just don't understand it, and that's why they're sort of outside of our organization. And that's why we can eat them, we can put them in parks and zoos, whatever we want to do with them, because they're outside of our organization. They're within our line of vision, but we are language beings. And that's
Yeah.
also why this feels so monumental, right? With the AIs today, like hacking language is basically hacking what makes us us. This
Yes.
is not the intelligence thing that's going on here. It's the thing between intelligent beings that's getting hacked. It's the
Yeah.
trust. It's the whole fabric of the human um, organization of the human society,
Yeah.
isn't it?
Well, and there's danger in that, because
Yeah,
when
definitely.
you
Sounds very
have
dangerous when I say it like this.
yeah, it's extraordinarily dangerous. But I mean, it's dangerous because once you make that realization that you can use language to basically hack thought, then it goes from something that's largely unconscious to something that becomes directed. That's what marketing does.
But not my thought. It doesn't hack my thought. It
Oh,
hacks
sure,
the thought of
it
society. It
it,
does
it
also with me. I know there's something. It changes some of my. I know that
right,
these biases that where you get some suggestions and everything. But it's sort of hacking the intelligence or the mind of society. That's what I'm thinking about with
yeah,
trust layers and all those things. It's changing the way language forms society, and it's changing. But because it's manipulating language, it's actually manipulating that mind, that the human hive mind that we've built for ages, right? We've been
yeah,
building the human hive mind to be faster and bigger and more connected, right? I studied history. One of the books I read was called The Human Web.
yeah.
It's basically that's what it is, and it's just going into all those things and saying, just hacking its way into it. Instead of we should have used it to learn how to speak to cows instead of using it to sort of trick our own
Well,
society.
that's
Maybe,
underway.
maybe.
I mean,
Mm,
there's already um, what was it? A video I saw the other day of a plant with a machete,
mm,
and the plant had basically, or the people that had set this up had said, okay, I'm going to secure a machete onto some kind of arboretum. I don't remember
mm,
exactly what the plant was, but at any rate, something large enough to be able to hold a knife.
mm.
And it then fed in based upon multiple cues things like what caused the plants to be able to move in certain ways. And you could basically got you at that point you could basically hack the movement of the plants to be able to facilitate things based largely upon the fact that you were able to change the light distribution on the plants so that they could react in a sufficiently fast period of time. Now, it's a very
Oh,
slow process, but the fact that you could do this and you could do it predictably basically meant that you're now hacking the brain of a plant, which is to me
yeah,
a phenomenal thing.
yeah. This
But
is
it
this is
but
this
it
is a great. This
requires the
is
analysis of what you do with a neural net to be able to say, here are the patterns that seem to occur
Yeah. You
when
need to
you
understand.
have
You need
these
to understand. You
stimulus.
need to understand the patterns that's going on in everything.
Yeah.
The
And so
fractals.
I wouldn't be at all surprised, if in fact I know for a fact that one of the areas that is actually under very significant academic study is learning how to be able to do communication in the languages that animals themselves utilize. And
Mm.
that's profound because it basically means that all of a sudden you can talk to animals.
And then I promise you, we'll all be vegetarians
Oh God,
because
yeah!
this will
Up
be too
until the
weird.
point where we get to the point where we realize that yes, you can do it with or with plants as well, and then things get
Yeah.
scary.
Then it
But yes,
gets really weird, right? Yes. But the point is, then we'll include it in our organization where we have language with it, or maybe we'll just exterminate like we did with the Neanderthals. That's a different discussion. But I think, and I hope the listeners have the same experience that they've gotten. I've learned things from this discussion. I've got new ways of thinking about things. My initial, I didn't getting you to explain the graph and the semantic web was something that made it make sense to me because I've had trouble just sort of grasping it. What does it mean? I'm not from that part of that's not what I've been working with, but it makes sense to me now. I think
yeah,
things are clicking into, and then the whole discussion where we sort of unfold it, and you can see all of the basically animal communication becomes a fractal. Like we're having it all becomes the same big system, and I actually like that. I think it's very beautiful, but I also think that this demands that we sort of in this conversation now just ties the knot a little bit around some of the things we talked about. So the semantic web and everyone being on the internet today, humans being basically an internet being as well, the metaverse and all that's coming. I don't think metaverse is a product, by the way. I think it's something society becomes, but
absolutely,
that's
yeah.
slowly. So if we talk about the internet as the metaverse instead, and then we say the AI and semantic web, how is all this gonna, change us? Is AI gonna change the semantic web? Is the semantic web connected to the way we just spoke about human organization? I- there's something here that I sense there's a connection, and I sense you have an answer for it.
Ah, uh, long term, yes, absolutely will change us. I think that we won't recognize society 100 years from now.
No,
It will be something that, quite honestly, if you don't have the necessary connections, the necessary interfaces, human society will no longer make any sense to you. Um, and I think a lot of people were expecting that it would eventually happen, but they were expecting, it's maybe 1,000 years in the future. And I'm thinking, no, it's probably closer to maybe 100, maybe even less than
but
that.
you're actually answering my question. I thought first you were not answering the question I was asking because I didn't ask the question. I just said some things, but now you're actually answering it. But my point is that AI is sort of this graph structure thing. The web is a graph structure thing. We are graph structure, or fractal.
Well,
Everything's a fractal, basically. How what is in 10 years? How will that structure look? Will we get enmeshed in all of this? Will this become one thing? I'm
well, I
just
mean,
trying to
that's
look ahead and see.
yeah. I
You're
mean,
talking
keep
about the
keep
hypergraphs, right? Hypergraphs. That's what you talked about
yeah.
the other day to me when we spoke. And is this going to be how's the hypergraph gonna look? A hypergraph is a
Well,
graph of graphs, right? Something's
yeah, I
happening
mean,
here, isn't
it's
it? There's some themes here that goes, internet, human society, AI. It looks the same in this conversation we just had.
yeah. Well, I mean, that's not surprising. Now, keep in mind that
No.
the graph and uh, when you talk about a graph, you're talking about essentially conceptualization. You're talking about something that you're saying, the graph is not the thing. The map is not the territory. That's Krzyzewski. Um,
Mm.
and you have to be very careful about that. You have to keep that distinction in your head because otherwise it becomes very easy to assume that the virtual and the physical world are the same thing, and they're not. We'll always
To
have
some people
physical
they are. To some
constraints.
people they are, Kurt.
For
The
some
problem is this:
people,
for some people, it is becoming that, isn't it?
yeah, for some people, some people are going to get lost in the web. They're going to get
Mm.
to the point where they have a great deal of difficulty being able to deal with reality because
Mm.
reality is just, it it's easier to basically deal with headspace, with mimetic space that allows you to do and be something different than you are.
But don't you think the
Then
metaverse is making reality into a graph? A privately held, constructed graph by someone company. No,
I don't
isn't that?
I don't I don't think it'll be, privately held. I don't
I don't
think
hope
that.
so.
Well, I think that if what's happened with OpenAI is a good example. And
Mm.
I'll come back to the hypergraph here in a second. But what's happened with OpenAI is that OpenAI basically started out with this premise of we will be the primary voice, of AI.
Mm.
And for that held true for about a month. And then everyone else said, money. We can make money on this. I'm not sure that you can, but we can make money off this. And so all of a sudden there was a gold rush and
Mm.
everyone else basically piled in. And what has happened is that in many ways, a lot of the foundational stuff that made OpenAI important are now making it less so because the innovation is basically occurring in many, many, many different pockets simultaneously.
Mm.
And that I think is actually going to become more of a reality. Yes, there will always be these big giants, these monoliths, Microsoft and OpenAI and Google and Amazon and whatever,
Meta,
the
yeah.
titans, if you will. But there will also be a much larger flourishing ecosystem of essentially localized data and localized information, localized communication, gaming, things along those lines.
Mm.
So I don't see unless something seriously wrong happens. I don't see there being a monolith coming out of this that will last for any significant space of time. Now, to get
Mm.
back to your discussion about hypergraphs, if you think about when you start talking, the big difference that you run into, and it gets really fuzzy once you start getting in the details. So don't, I'll say this: there's a mathematical definition of a hypergraph that's been around for a while, and it basically says that if I have an edge, I can have multiple sets of things attached to either of those pieces of those edges. And in fact, you can do that now with a graph. It's just that what we lack right now is kind of the infrastructure, the language, if you will, to be able to
Mm.
really make use of that. And that's evolving. I think that will actually happen with time. But the other aspect of hypergraphs that I think is just as important is the fact that they
And a
evolve.
hypergraph is a graph of graphs, right?
It's well, it's yeah, yes, you can think of it as a graph of graphs, but then you have to say what is a graph. And a
Yeah,
graph
obviously.
can be anything from a collection of things to structures to just individual tokens. There's a lot of different ways. That's why when you talk about it, my own personal definition basically says that a graph a hypergraph is also fundamentally temporal in nature. And that is to say that it does in fact make use of a certain underlying ontology that says I have events, and events in turn are events that impact upon the various things that are described in the system, the entities in the system, and can
Mm.
essentially allow you to see evolution over time. And because you're talking about a system where you do have to have graphs of graphs of graphs of graphs of graphs, you can carry this to any level of abstraction.
Mm.
Hypergraphs in that regard essentially then become kind of a minimal necessary technology to discuss all of the rest of it.
Mm.
But in essence, what I see a hypergraph evolving into is what we call a digital twin. Right now we talk about digital
Mm.
twins, but it's a very fuzzy idea. Most people don't have kind of an intuitive notion of saying, okay, I have a virtual representation of a physical thing. Um, but in reality, what you're talking about is in order to describe a physical thing, well, that physical thing is physical because it has existence.
Mm.
It is basically something that occurs in time as well as in space. And
Yep.
because of that, because you have those constraints, um, you can do things with these kinds of graphs that you can't do with things that are largely static. Because an organization changes. People quit, people leave,
Mm.
people
Yeah.
die, they retire, new people come on board. You have reorganizations. Reorganization is a very strange thing in the semantic world because it says basically, okay, I'm throwing out this whole section and now everything is different, but it has all of these people that are used to be in this and are now in this. Um, and it's that concept that I see with hypergraphs, that I see this next stage of evolution from the symbolic AI side of things that then, can be referenced by and integrate with generative AI, that really describes the overall architecture of what these large scale systems and small scale systems for that matter look like.
Mm.
You
Mm.
know, the problem that you have with most graph structures is that querying them is difficult. It requires a very specialized language. But if you have a mechanism that basically says, okay, I can do something that will make the query process simpler. In this case, there's something I saw just the other day called RDF to VEC, which basically
Mm.
says here is a map or here's a way of converting an RDF structure, which is a descriptive language. It's a resource description framework language. Um,
Mhm.
but converting that RDF structure into some kind of um, a vector that can be put then into this meme space, this information space. That's where you begin to get the correlation between the two. If I can then say with that vector, look, I'm going to associate with that vector, among other things, identifiers. So that when you talk about this concept, there's an identifier I can extract that says, oh, according to this particular ontology, I have this entity that I've created in my LLC that's part of a construct that I can then use to not only say, okay, that is what this is, but also that I can use because you have the ability to deal with temporal capabilities of essentially then say, here is the provenance of these particular entities over time. And this is a fundamental problem that we're facing right now because there's no way at the moment when I go in and I create a training set that I can actually tell you after the fact where that particular thing came from. The left cheek
Mm.
an old man. I can't tell you where that came from
We can do that
with
with a
this,
hypergraph.
but you could with the hypergraph.
Hmm.
And so the
That makes sense.
hypergraph essentially just becomes, it works with an AI or can work with an AI to do a number of interesting things, but they're essentially parts of a larger overall system, kind of a lambda graph, if you will,
Yeah,
or a
yeah,
llama
yeah.
graph.
That's interesting. So, but that doesn't. You were saying something about how the future will look, right? With that, and just I'm thinking one thing, right? So, should we call it the metaverse or should we call it the hypergraph, Kurt?
Uh, you can call it whatever you want. But to be honest, I think metaverse was basically a construct that first appeared in Snow Crash in Neil Stephenson's work.
Mm,
And it had been around for a while. He was not the first person. He was just the first person to basically say, hey, let's put a name to this and describe a virtual reality. And this is back in 85, 86, somewhere that time frame.
mhm.
Um, but its significance was basically that he painted this virtual world and made it very clear that there was a virtual world. That's why Snow Crash is actually considered to be one of
But
the
just like you
Burr
said,
books.
this digital twin thing, right? With the
Yeah,
hypergraph. That's why I'm asking, right? So,
yeah,
is it really just a hypergraph? Is that
it
the best
is. I
way to
mean,
understand what we're going
it,
to build?
if you look at a hypergraph as basically being a virtualization, and then you say, wait a second, what's happening in society? What's happening right now is actually very intriguing. Um, you have big corporations, but big corporations are actually disintegrating, and it's really it's unfortunate for the people that have been laid off. But what I think is going to happen is that, and has been happening for a while, is that we're basically virtualizing more and more and more of a corporation so that it's essentially a virtual rather than a real entity. Now, there's real people that are doing the work behind that virtualization, between when I
Yeah,
okay, I'm working with Salesforce, for instance, or
yeah,
I'm
yeah.
working
I get
with,
your point.
but the point is that I'm working with Salesforce as an abstraction.
Mm.
I'm not dealing with Salesforce as a company. I'm working with Salesforce as an abstraction that provides a set of APIs to be able to facilitate a
But
certain
hasn't it
set of
always been
operations.
like that? But Kurt,
Well,
it's always
certainly.
been like that.
Well, but it
We built the
hasn't though.
pyramids for the pharaoh, or the idea of
Yeah,
the pharaoh, or something like that. The idea of
but
Egypt, right? So,
but the difference there is
where
that
is Egypt? Who knows where Egypt is?
the difference is that the is that normally abstractions don't talk back.
Mm,
Now we're getting to the point where I can say,
yeah,
I talk to an abstraction of Salesforce, and Salesforce will talk back to me. And
yeah, because
it
and
becomes this question of saying, well, what is it that I'm actually interacting with? And it becomes
so
I'm interacting with it.
this is a vision of the future, isn't it? Then,
Yeah, I mean, but it's not as you point out, and you're exactly right. It's not something new. It is simply as corporations or as entities basically spend more and more time abstracting out these various services and components of themselves, what will happen is the organizations themselves are contracting. They're becoming smaller. They're becoming more decentralized. This is why it is so hard for corporations to basically get everyone to come back into the office because
yeah,
people have basically all begun realizing, hey, I can deal with the abstraction of this organization better than I can with actually having to be on premise. I can
mm,
interact with it better. I have better control over my own autonomy as a separate entity, as a separate business, if you will. Um, and that process is going to continue. It's these companies are shedding workers left and right. And right now, they're not necessarily doing it because they're thinking that this is all in response to to AI
They're also
or as
hiring. There's
elements.
also a lot of hiring. It's just not just it's not just dismantling. It's just I don't see that way. I don't see the economy that way. There's of course there's some blips, but I don't
Yeah,
know.
but the point I'm trying to the point I'm trying to make here is that what's getting hired is increasingly, or where the hiring is taking place, is increasingly within these separate virtualizations. So, you're seeing
Mm.
more people organized into, hey, I'm dealing with
Yeah,
Salesforce.
the
Salesforce
gig
itself,
the gig
the gig
economy as well,
economy,
right?
but
People
it's
sitting
it's
everywhere. Yeah.
yeah, and it becomes essentially graph-like in its nature, and
Uh,
that's where I see society moving, is that
But
the
you've
graph
made me think
interactions.
about the whole you talked about the generative AI and the LLMs, the chatbots here, the chatty bots or whatever, stochastic parrots as Stephen Pemberton called them, as as corporate beings. And now we're saying that the social constructs, the corporates, will start talking back to us, and and that sort of blew my mind just for a second there. It
Yeah,
actually did. The thought of constructing Egypt, and then suddenly Egypt talks to me. It's like waking up at night as Joseph, right? No, Samuel in the temple, and someone saying, calling for me. You know, you remember? I don't know if
yeah.
you know that Bible story, and speak,
Oh,
Lord, your
no, no,
servant
no,
is listening, or
I'm
this.
familiar with it.
But so you suddenly you're talking to Israel, you're talking to Egypt, you're talking to the construct.
Right.
That's a
And you're
weird thing,
exactly right.
actually.
No, it does change everything, because
Yeah.
once you get to that point um, where essentially when you have the virtualization within organizations, basically
Mm,
people increasingly moving outside of the physical construct of having to congregate in a single building, and say
mm,
instead, no, look, a lot of the process of reorganization is largely a logistical process of dealing with physical allocation. Once you turn that into a virtual process where organization simply becomes what particular bucket you happen to be working with at the time, then the overall notion of an organization is something that is stable, from the standpoint of okay,
yeah.
this is the structure. It goes away. It's
That's why you
simply
need the hypergraph as well, the temporal
exactly
level, the saying why are you connected to this? When have you been connected? The LinkedIn CV is sort of the hypergraph, isn't
is
it?
it. Oh, very definitely, it's a hypergraph.
Mm, yeah.
I mean, it's
Oh,
it and again, a hypergraph is still a graph. It is still a description. It's a description with its own internal organization.
what was it
Um,
movie was called? Tron, wasn't it? Where they sort of come into the computer world or the internet or
yeah,
something. Are we see this? Is this now? I'm just thinking. Are we to sort of wrap it back to the semantic web? Are humans now becoming an entity in the semantic web? Is that's what happened in 10 years? So people
uh,
saying internet or AI. I think it's internet and AI, and it's actually humans, internet and AI,
yeah,
and that's becoming one big graph and one big hypergraph. Is that what we're getting at?
yeah. Essentially, I mean, you talk about things like agents
Mm,
and agent APIs, which is now suddenly all the rage as people are beginning to wonder, well, what's next? And
mm,
what you're talking about there is essentially, again, the question of at what point do you distinguish between a person, a business, and an artificial intelligence? Because they
mhm.
begin to look a lot alike and under
Yeah,
a
yeah, they do,
sufficient lens.
and I'm just a node, right?
Yeah,
I'm just a node. I'm becoming a node. That's the point.
yeah.
I'm getting mapped out.
But you're a
I'm mapped
node in
out.
a graph that's
They
constantly
figured me
changing.
out. You're making me want to just run off to the wilds and not be mapped out anymore. But I am mapped out a lot, and my entire online existence is mapped out. And
I
now,
am
from
not
now
a
on, I'm going
number,
to think of that
yes.
as no. But for now, I'm going to think about myself as being just a node in a graph, in a hypergraph, and it's just going to be yeah, you've really positioned this for me. I think that's actually very brilliant. I love this.
Yeah.
I've really explored things here. I don't know if you've explored a lot, but I've explored things, and I like that.
No, I mean,
Uh,
there's a lot of stuff that I'm learning out of this too. So it's um,
I think
no,
But I think, Kurt, I think we've already by far become the longest episode of The Only Constant. And if I'm not gonna go, full 3 hour episode stuff, I think it's time to maybe say that this has been a really nice conversation, and that people can connect with you and subscribe to the Kegel report to get more of your insights. And maybe we should plan in a year, or see, has the world come closer to whatever we talked about in the end here. That would be fun as well, to maybe do a follow-up.
I would
um
absolutely love
but
that.
then also but then also there is this one question left here in my podcast. It's called The Only Constant. So I'm going to ask you, Kurt, what is the only constant?
I would have to say it's change. The what we're dealing with, all of the discussion about graphs, they're representations. They're simply ways of being able to say, I am translating a model of the world as we know it into some kind of virtual representation. That model is not static, it's evolving. The fact that you may be in the graph does not mean that you are, in fact, of the graph. It does not mean that your life is controlled by the graph. It simply means that, what you're dealing with is a record. It's something, a graph is like any other data structure. It is a record of what has happened in the past, and it can be used to extrapolate what will possibly happen in the future. But it is simply a tool. Ultimately, I think that we live in a world that is neither fully static nor fully chaotic, and I'm thankful for that. Because if we did, or if we lived in either one of those extremes, nothing would happen, or too much would happen, and nothing would matter. Um, you have to have a balance. You have to have a point where, as things change, they do so in a balanced manner, and something that basically, as you add, um, as you change things in the world, other things change in response to that, which change other things, and that is what a system is. So that is what society is. That is what society is. That is what culture is. Um, it's a system that is, like all systems, it evolves over time. And that evolution is something that we have to basically recognize as intrinsic and necessary. You can't have organizations that are truly stable, because at that point, it simply means that nothing is happening around them, or because they have chosen to not listen to what is happening around them, and they will eventually die. So, that is the only constant.
That is a really great answer, Kurt, and a really nice wrap on everything we've spoken about. And I really love that answer. And I also love that it's the original only constant. So
Yes,
thank you for that. And thank you for being on The Only Constant today with me. It's been a pleasure speaking to you, and also an
likewise.
honor to speak with someone, a legend like you. So hopefully we'll do it again. Thank you very much, Kurt.
Sounds good. Take care.
You've listened to The Only Constant, a podcast sponsored by Basico.